Math is not a magic, but it is a language. And today, we are going to translate it for you.
Ever seen a negative angle on planet?
Don't worry, we have the identity keys to unlock the solution.
From simple rules,
To complex verifications,
we got you covered.
We are the Group 4, and this is Trigonometry, the even and odd edition.
Before we start with even and odd functions, let us recall the basic identities that we will use today. This is our tools. So for the reciprocal identities, we have here sine x is equals to 1 over cosecant x, cosecant x is equals to 1 over sine x, cosine x is equals to 1 over secant x, secant x is equals to 1 over cosine x, tangent x is equals to 1 over cotangent x, and cotangent x is equals to 1 over tangent x. And for the quotient identities, we have here tangent x is equals to sine x over cosine x, cotangent x is equals to cosine x over sine x. And for the Pythagorean identities, we have sine squared x is equals to cosine squared x is equals to 1, and 1 plus tangent squared x is equals to secant squared x, and 1 plus cotangent squared x is equals to cosecant squared x.
Now, let's master the rules of negative angles.
Even functions. The signs stay the same. Cosecant negative x is equal to cosecant x. Secant negative x is equal to secant x. For the odd functions, the signs flips. Cotangent negative x is equal to negative cotangent x. Cosecant negative x is equal to negative cosecant x. Tangent negative x is equal to negative tangent x. Sine negative x is equal to negative sine x.
Got it memorized? Awesome! Let's put it to the test.
Here are the equations we will verify today, ranging from simple to difficult. Hi everyone! I will be the one who will answer equation number 1. So we have here equation number 1. Cotangent negative x is equals to negative cotangent x. So let us verify this equation. So as we all know that cotangent is a quotient identity is cosine over sine. And since it is negative, so negative x. And also this is an even and odd identity. So cosine negative x is equals to cosine x, and sine negative x is equals to sine negative sine x. And let us move out the negative sign. So negative cosine x is equals to sine x. And it is also a quotient identity, so negative cotangent x. So, we have proved the identity that cotangent negative x is equals to negative cotangent x.
Equation number 2 is mine. Now, let's start solving.
Let's solve the equation number 2. Negative cosecant x is equal to negative cosecant x. We all know that cosecant negative x is reciprocal identities. So we need to write it into 1 over sine negative x. So after this, we apply the rule of odd and even identities. So we need to write it into 1 over negative sine x. And after this, we need to move out the negative. So negative 1 over sine x. And we all know that negative 1 over sine x is negative cosecant x and equal to negative cosecant x. And therefore, we've proven and verified that negative cosecant x is equal to negative cosecant x.
Let's proceed with equation number 3. So let's proceed with equation number 3, which is the sine times negative x cotangent times negative x is equals to cosine x. So we have to apply the rule of even and odd identities, which is sine times negative x is equals to negative sine x And then the cotangent times negative x is equal to negative cotangent x. Then we all know that negative times negative is equals to positive. So we have to copy sine x times cotangent x. So in this equation, we have to apply the rule of the quotient identity of the cotangent x, which is the cos x over the sine x. So we have sine x times cos x over sine x. Then after that, we have to cancel this 2 sine x and the sine x. Then we have arrived the answer of cos sine x and is equals to cosine x. So therefore, we have verified that sine times negative x and cotangent times negative x is equals to cosine x.
Now, let's proceed with equation number 4. So, let's verify this equation. Cosine negative x times tangent negative x is equals to negative sine x. So, we all know that cosine is an even function or identity. So, we should apply the rules. For cosine negative x, so it will remain as positive. So, we can write this as cos x, and for tan, it is an odd identity or function. So times tan negative because it is an odd and equals negative sine x. So since we are, or the other side is negative sine, so we should find something that we can have the sine. So for tan, we should change it into its quotient identity. So we all know that the quotient identity of tan is sine over cos. So since this is negative, so we should apply negative. And we all know that sine is an odd function or identity. So we'll write this as negative sine x. And for cos, since this is an even identity or function, so we'll write this as positive. So times cosine x. And with that, we can just cancel cosine x, and it will remain, and the remaining would be negative sine x equals negative sine x. So we have proven that cosine negative x times tan negative x is equals to negative sine x. It is verified and correct.
So let us proceed to the equation number 5. So we have here sine squared negative x over cosine negative x is equals to secant x minus cosecant x. So let us solve this one. First, let us apply the rule of odd and even identity for sine and cosine. So sine squared negative theta is equals to negative sine theta squared, since it is sine squared, over cosine negative theta is equals to cosine theta. Next is simplify the square. So it will become sine squared theta over cosine theta. And since sine squared theta has an Pythagorean identity, we can write it as 1 minus cosine theta over cosine theta. And we will split it into 2 fractions, and it will become 1 over cosine theta minus cosine squared theta over cosine theta. And we will simplify this so we can arrive the equation. So 1 over cosine theta is a reciprocal identity, or has a reciprocal identity of secant theta, minus cosine theta, since we can cancel or we can cross out the 1 cosine. So we just have arrived. There, we have proved that sine squared negative x over cosine negative x is equals to secant x minus cosecant x.
Now, it's your time to solve. We have prepared 2 equations for you.
And that's the secret.
Negative angles, done. Complicated equations, done.
Let's just get is here, right?
We are the Group 4 signing off. Stay smart, sharp, and keep solving.